So hello, this is HD robustness test regular meeting, the first one I hopefully with in some series. So I wanted to gather and organize a dedicated meeting so we can talk more and share knowledge about the testing framework that we have, and um, hopefully you're already aware of it, but it's definitely an area that I would like to see more reviewers and approvers. So we can, and I think it's a great opportunity for people to get involved more in etcd. And I've prepared some agenda for the first meeting, so I don't lose track, and we go through some high level points. But feel free to to speak up, ask questions, whatever. Whatever is questions you have, so we can so I can help with that, because the goal of this meeting is more to discuss shared knowledge and exchange ideas. There is it's still pretty, or this area is pretty still new for me, and I expect new for many people in HD community. So I hope that this series of meeting we can improve the current situation. So yeah, high level goals. Maybe like my question, high level would be, I have some ideas, but I would want to maybe hear more from you. What would you like to get from the meeting to make sure that I do my best in trying to let me scroll the proper size so that you can I can first help understand how I can help you with, instead of trying to push over agenda. Is there anyone that would want to um, speak up or?
No, I just wanted to say thanks for doing this. Yeah.
Mhm. Okay, let me close my window. It's a bit noisy. Yeah. Okay. So feel free to add your thoughts. They maybe after, like during the meeting or after the meeting. Okay. So
Hey, hi, I'm Alay. We met briefly at KubeCon. I wanted to add something here. So one of the things that we are really interested is getting and testing the stream list feature that's worked on in Kubernetes API server. From this meeting, I wanted to understand what kind of testing and robustness assurance is required for that feature to graduate in Kubernetes.
Oh, great. By stream list, you mean watch list, or?
Correct. Yes.
Okay.
Those terms are used interchangeably. I'm not sure what is the right way to denote that feature.
Okay, sure. Great. That's yeah. Any other thoughts or asks?
Sure. Go ahead.
Okay. I think it would be helpful to sort of discuss what we're trying to prioritize in robustness testing. Like, are we trying to work on adding tests for certain things right now, or are we trying to improve the framework itself? And if so, what do we need to do in the framework right now to make it better?
It's a very good questions. I have some ideas. I think we maybe I know if I discussed some of them, but yeah, that's a very important topic. We cannot the goal of the test is not to add more tests, is to cover specific use cases. For example, like watch list, to make sure that we can build features like this. So I will definitely try to remember to touch on that. Any other suggestions, or we can move forward? Okay.
Excuse me, I have one more suggestion.
Yeah, no problem.
I was wondering how we can validate if HTTP server working perfectly under some circumstances, how we can validate HTTP.
Okay. Yeah, that's a good question. Okay, I think I have some idea. I will try to touch those things during today, but please feel free to remind me. I will try to get through them. But yeah, just to make sure. Yeah. Going to the next point, which is the format. I've been thinking, is it more like lecture, or should I only talk, or should we do workshop? I think both formats could work here. I assume that for the first meeting, I will be mostly talking and presenting what is the current status, and maybe trying to go through some examples and go through analyzing some examples, and with time and future meetings we can slowly move to workshop. But feel free to follow and try to run the commands on your site. Happy to get more people looking at the problem. I will be during the time today, I will be going through some old reproductions and will be running commands and showing you commands. And I will provide the command. I will try to provide the commands in the document. So yeah, if you want to, yeah. So to summarize, I will be talking, but if you want to run the commands, I will be happy to, and have some problems with running the commands, I will be happy to slow down a little and help debug if someone has a problem. Okay. Is there any questions about the goal of our plans for the meeting? I hope I stated. I didn't talk through them, but yeah, they are stated at the top of the document. That okay. Let's go to the second point. Introduction to robustness test. That's the interesting part that everyone came today for. Let me think. I can share my IDE. Yeah. Okay. Robustness tests. If it's not, let me know if you can see it, or should I increase the font more? Yeah. So I just have an IDE opened on the project. So this is my etcd repo. It's on latest main branch. And the interesting directory, hopefully everyone had time to go through the prep. But this is the interesting part. Under tests, there is a robustness directory. I have written some README that goes high level and describes high level ideas put here, and we'll be going through some of the examples and talking about the high level code, or to give some short code overview. The framework is written as a Golang tests, which means there is a test mine, and test mine we just run tests, and we have two main tests, which is test robustness exploratory and test robustness regression. The difference is I introduced them late because the difference between is just one runs. They run different scenarios that I run in different, we run them in CI, and depending on which CI is, if it's pre-submit or is it a periodic, we run different cases. But high level, they only differ by configuration. So each of those has its own list of scenarios, and code here is, yeah. So for example, we will get through some historical issues, but to give you an example how they are implemented, for example, we have an issue 14370. It was a single node durability issue. Is there any question?
Wih, rame nih. Ya, dom botak. Ya, dom Didi juga.
Sorry, I don't understand you.
Iya, seru banget. Males gue ngumpul.
Okay.
Coba. Bibir.
Yeah, I think we need to mute. Yeah. Okay. Moving on. It's an issue. It's linked in the document. It's etcd durability, and what is like from robustness perspective, it's a codified etcd configuration, which is visible here. It's one node cluster because it's a durability on one node issue. It has fail points enabled because the durability happens during a specific fail point or specific point in code if it panics. So we need to make it reproducible. We inject this specific fail point, which is called raft before save, which is a place in code that directly tags some code line in code. And we have a framework that if we enable go fail, the framework is called go fail. So if we enable it in tests and we say we want to, in the robustness test, we want to use this fail point, it will start etcd and crash it on this exact code line that is specified. And to find the code line, you could go to the fail point and copy its name and find it. Like this is example. I think this is the. Is this the fail point? Let me check. Just raft before save panic. Raft before save. So it will be somewhere here. Raft before after save. Raft before somewhere here. One of those. You would need to find something that is go fail or comment with go fail and this structure. And if you find that by the name or here, raft before save. So it's robustness test will automatically, or if you compile etcd with fail points, robustness test will detect that and use the fail point to crash etcd at this exact point. And this is how we can get 100% reproducibility on this issue. We pick some profile of traffic. The profile for traffic just describes number of clients, number of QPS that we need, and some parameters. It's just because of limitations of the system approach, we need to limit and pick some shape of traffic. We are using this traffic, we are picking some traffic, let's say request in the traffic, and we have a structure that defines what kind of requests can be done in this shape, and it's here it's just percentage of probability of each request. So we do 15% of 15% of on average, 15% of requests should be gets, 15 should be lists, and so on. So this is the scenarios. We have scenarios for each issue, and you can easily run them and reproduce them. I will show it later. But yeah, this is the main robustness test, or in each test we evoke the test robustness, and test robustness basically is the main function that runs the robustness test. The important part is, let me think. We first, where is it? We create the cluster. We pick the fail point, either it can be a specific fail point, or if there is no specific fail point, we'll pick a random fail point available for this cluster configuration. So there is some logic that checks available fail points in this cluster running in this version and picks one of them. Yeah, I think this confirms that the fail point is correct, and the one that runs the test is this runs the test, and then we collect from tests, or before we create all the tests. Results from the test are gathered into the test report, and we run the test and collect all the client requests in the client report or client reports, which describe what was the request sent by client. And request sent by client treat etcd as a black box, and they send just the requests from the traffic I mentioned before. And the reports are basically what was the request, what was the response, have it succeeded, when the request started, what was the time of the request being started, and what was the time of the request finished. And that's all. Like, this is the report. What is important, all the structures here to describe the report are just Golang structures, and they can be dumped as a JSON. So the main thing about reports, they can be dumped as they are dumped after, if the robustness tests fail, they're all dumped as a file. Due to some performance reasons, we also read etcd wall to know which requests really persisted. I will not go now into details, but it just are, we read the wall and use it for some validation to make sure we don't. It's basically, we try to avoid, when trying to find possible solutions, we try to avoid going too deep into paths that lead to blocked, that following them doesn't make sense. So we just like cut some, imagine a graph, and we just cut some branches that are not usable to search from. And we also have some progress notify validation. It's just because we need to make sure that the progress notify exists, and then we run and validation. We spent some time on the code. I don't think I will go deeper in it. Maybe discuss high-level structure of the directory. And the directory had, like, the structure is created based on how the project, like the framework evolved and in what direction. So not everything was moved to a specific directory, but things like fail points. We have so many different types of fail points that it was worth to separate them. So the fail point directory has all the fail points that we have. Like, there are fail points based on killing the server. We have fail points based on panicking at the specific code path. We have fail points for restoring cluster or restoring member by replacing it, or like there is a process of restoring member from if there is a corruption member with so you could etcd supports a scenario, so I added this. There is some network separation tests. There is some delays, so we delayed in some places to simulate raft being slow, and snapshot sending and other. You can check all the code is available, and they are moved to separate directories. Leave it. We have identity directory. This is specific because when we are sending requests, we want to make sure that they are pretty unique. We can make some assumption about the uniqueness. So we have an interface for providing unique identifiers for different types of different consumers. So we need to have each stream needs to have a unique ID. So we have a provider that provides us ID for that, with ID for requests and ID for clients, and they're separate. It's just very simple code. It's just pretty independent of the project. The main, both simple and very complicated part is the model. Model is, in the presentation, I treated a little bit and said the model is very simple. The reality is model is very complicated, unfortunately. The code for model starts on line 88 now and finishes in online. It's around 100 lines, and some functions are already separated. And the model is already not just counter. We have and a map. We have map, but we also have revisions. We have leases, and they complicate things. And this is only for so-called deterministic model. There is a comment that explains it. High level, because the method we use to find issues, we need to. We have a model that assumes that this or it can assume optimistically that requests succeed, but we also have a model. We need to wrap it to so-called non-deterministic model to assume that some requests can fail and still succeed. And they are described here. I will not go too much for now into that. I recommend you to read the comments and ask questions if you need more clarification. There is some directory for options, because one of the issues we had, around half a year, was about specific etcd configuration. So we want to do some. We have a directory that allows you to pick or to randomize etcd configuration. We don't have a lot of parameters that can be randomized. So if you want something to work on, you can look into that. The goal is to not only test etcd in one snapshot count configuration, but test it in different multiple values. So that this is the directory that defines how you can parameterize etcd in robustness tests. So that's the directory. There is a report directory. A report directory goes into collecting, or it defines the structure how the report should look like, or the main report from robustness test, and then defines how you can save or load the report. So every time the robustness test fail, they will be saved in a file, in a directory with some structure. So this whole package is responsible for loading this or saving this directory and then loading it back, so you can reproduce it. And we will go into that later. There is a test data directory. This is a newly introduced or for usage and described in the README how you can use this directory, that you can copy some failures into this directory and then run a test, and it will reproduce or rerun the the report for you to revalidate it, and it's pretty useful when you're iterating on some failures and want to find if the issue is related to etcd or robustness test. There is a traffic that defines two different shapes of traffic. One is one is etcd traffic, which is a pure normal, like, or at least how different methods how you could talk to etcd. But also there is the Kubernetes traffic, which tries to simulate more how Kubernetes uses etcd. And it's just like the difference is etcd just do simple get, read, store and read values, and Kubernetes has some code that simulates sub resources and watch and reconcile loop. You can go into that. So it's part of my goal and goal of robustnesses, or like the roadmap to not try to test all the surface of etcd contract, but or how etcd API, but try to focus on how Kubernetes uses etcd and try to test this as much as possible, because it's more critical, at least from Kubernetes perspective and etcd project. The last directory is the validate. The validate directory describes how validation works. Check. Usually validate. Like usually if you look into directory, there is a file called the same as the directory as a main file. So the main intro function into validate is the validate and return visualize. Return visualize comes from limitation of the library that we use. It doesn't make. It's a hack. I need to return. It needs to return a function to visualize results, as we will see. Validation is this is the main flow of validation. We first validate some assumptions. During robustness tests, always fulfill those assumptions, but maybe you can come with your own report, and this report breaks one of those assumptions. I had case that I by mistake merged two reports, and they broke and tried to debug the why it failed, and I found that it breaks the assumption. So we start from validating: is the report correct? Does it make sense? Can we even validate it? Then we do some history patching. History patching is a way to cut off those paths that lead to cases that are not interesting, and so it optimizes the validation. It's an optimization. Then we run with linearization. Linearization takes set of operations and tries to validate: does etcd model follows can we reproduce the list of operations on etcd model? So it tries to answer questions: does this distributed system that we run client requests against, does it follow the model as we think it should behave as? So this is the important thing, or first really important step. And we use a dedicated library for this that is called Porcupine. And you can look it up, but the main thing is linearization can easily run above the timeout. We set a timeout for it because it's an NP complete problem. And without the optimizations I mentioned before with patching the history, this can easily run in hours. Like I had it run in hours and not get any results. So because we run some optimization, it allows us to usually get under a couple of seconds. But for edge cases, and because it can run in CI, which is sometimes not very powerful, we limit. I think the current timeout is 5 minutes, and it can give you 3 results: either the model is broke, or something goes. It found a fault, so there is an illegal transfer. It can time out, and then results unknown, and it can succeed. If it fails, we don't we abandon and say we failed and don't follow through. And next things, oh, this is interesting. Oh, okay, it makes sense. Yeah, next we validate the watch, and this goes into answer: can we validate the watch list feature? This is the main important thing about any about recent optimization in Kubernetes that want to double down on using watch to optimize, like watch list and other stuff, is our validation of watch. It's very like it's grown more and more complicated. At the beginning I thought it will be pretty simple, but it's pretty it's not as easy as I thought. High level, there is I try to make it semi consistent with documentation that is published by etcd, which means there is a set of guarantees that etcd says about how what should behave, and we test them, and we have a function per each guarantee, and we test it. So we guarantee that all the events on watch are ordered, they are unique, which means there are no duplicates. There is atomic property, which is important for which is something that Kubernetes doesn't have, but it's important for etcd to guarantee to allow multiple transactions, or to allow transactions that have multiple operations. And because Kubernetes doesn't support that, it doesn't need that. It doesn't have this property and doesn't need it, at least for now. There is discussion to extend Watch API in Kubernetes, or at least I talked with a couple of people about this. Watch is bookmarkable, which means you can etcd can give you information about your progress, so-called bookmarks in Kubernetes. In etcd, it's called progress notifies, which can allow you to make to not do additional work because of not if there is not a lot of events on the watch. So you don't need to start from very beginning. You can get a bookmark and know that you're much further in the process. etcd watch also guarantees that it's resumable, which means you can resume it at any revision, at least in watch, if you're within compaction window. etcd watch is reliable, which means it doesn't miss any events between them. Kubernetes also uses prefkv, so we test prefkv thanks to MacDev work. So we test if the prefkv is correct, which is an option that is not default in etcd, that Kubernetes uses to know what was the previous value of the object after we change it or delete it, or after we change or delete a key. It's critical for Kubernetes correctness. And is create value, which is also pretty important for Kubernetes. So each event, because etcd itself doesn't distinguish between create and update, it just has a put method. So fact that watch informs users about the is create value, was this first time the key was used or the second time, is very important. So we validate all of those. And each of them is very critical, and you could not build some solutions like Kubernetes, watch cache, without those guarantees. And at some point they will break. So we always check them. Last thing we check is serializable operations. It's named from etcd. It basically means that you can ask about alt revision, and so you can, in etcd, you can do two types of requests. You can do linearizable requests, which means give me the latest value from the cluster, or you can ask about some old revision. So we do the serializable requests are requests about old revisions, and we do them and validate them separately because of performance. And so we validate that, user, if when they ask about the old revision, they got this old revision. And that's all. We return a visualize function because you cannot pass it differently, and this function can be used to create a report, which we will see in a second. Are there any questions about the code overview? It was not very short, but I think it was exhaustive, or I hope.
No question for me. Thank you, Marek.
Okay. Yeah, so hopefully I overviewed all directories. Maybe in future meetings and discussions, we will go deeper in each of them. Each of them is a pretty substantial, I would say, area that could be developed on its own. And we just need to usually prioritize high-level goals. Have I, I would need to go deep. I try to answer the watch list. I would need to go deeper. How watch list works and how to guarantee. But my understanding is watch list should be. I mean, the guarantees that watch list needs are tested already by the robustness tests. The question is, should watch list test it? Have a similar test as robustness test on its own, but it's hard. It's a bigger question. I mentioned the what we prioritize in robustness test, which is a Kubernetes contract. I didn't mention, or I mentioned Kubernetes. We have Kubernetes traffic, and we try to prioritize how Kubernetes uses etcd. But in essential, it boils down to Kubernetes contract. I don't think I will provide a link to the document if someone is not aware about if someone haven't heard about this. And yeah, how can we validate etcd? I will go into it shortly. So let's now reproduce some of the historical issues. If you directly just open the README, you can see the instructions how to run robustness test. The interesting part is analyzing the failure and examples. So first example is the first issue that is listed in the document, which is 14370. So just let's maybe test it. And for that, there is a ready make file that has commands. The make file is pretty simple for the issue. It just compiles the binary for 354, which was the version affected by it, and then runs the robustness test, and it points to bindir, which is a way for a supported way to use etcd binaries from different directory and just run robustness test. So yeah, let's reproduce it. So we can just call make test robustness issue 14370. And it should take some time. Is anyone following the reproductions? Anyone needs any help? Is it clear? Okay, I hope it's clear enough that no questions are needed.
I have a question. Based on your introduction, it seems like all the traffic is randomly, right? So, so I'm thinking, for the known issue, should we put the test in the end-to-end test? I think is my it might be easy to test to verify our fix is okay. But when we put the but we
Yeah.
we try to put here
I
all the
think
traffic. Yeah. So
I
sometimes
think I
it might
understand.
fail. Yeah.
I think I understood because before I recently find an issue, and I think high level the question is should we add the tests or end-to-end tests for a specific issue, and the answer or high level I approach each correctness issue or in I try to be as broad and dedicated in each area to so we make sure that we cover and never repeat the same mistake again. So for exactly the issue of decrease that if we work on revision decreasing that is mentioned below in the document. You introduce the end-to-end test, which is, I start with end-to-end tests. If we know how to directly reproduce the issue from the code, we should reproduce it from the code. It's a first thing to confirm there is regression. Second thing to confirm that this doesn't repeat is to add a robustness test. And robustness test is a broad exploration of, like the name of test of exploratory exploration of different states. But every time we find a new issue, the assumption is this issue is outside of domain of the current robustness test. We should grow robustness test to cover this new domain. So we should add, I don't know, missing fail point, missing traffic shape, missing, I don't know, HCD configuration to robustness tests. So we then are able to possibly reproduce them through exploration. And the third issue is, okay, if I have a set of, if I have robustness tests that might reproduce this issue again by exploration and similar, and find full class of these issues again, can I be really sure that the robustness test will forever in future reproduce this issue? And the answer is unfortunately no, you cannot be, because most of the issues are not in robustnesses are not 100% reproducible. They can be 80%, 50%, sometimes 1% of time we reproduce it. That's why we usually run in reproduction like here only 100 times, because you don't have guarantee. I'd like to add for each issue, I would also like to add a scenario in the makefile so that we can periodically manually verify that we can still reproduce it, even if it's just a theoretical as an example to show to someone else how we can run and reproduce this issue for like future learning. So for this your issue, I would like to at some point to work on adding it to robustness exploratory and add a test like this for it too. But
Sure,
if you want
sure.
to help with that, I would be happy to collaborate.
Okay, I will try it.
Yeah.
Thank you.
Okay, we have reproduction. What is important is unfortunately, you need to find an interesting log. The interesting log, I mean, it's mentioned in the README. You look for history.html and can take this path, open it in your browser. For that, let me share new and share here. This is the so-called linearization. So this is what Porcupine, the library, provides us, and it's some visualization of all the operations, so key value operations on etcd that happen. They should always start with, or there are multiple clients and so-called, and they can be really large amount of clients here, much larger than technically are in the much larger than are defined there. And the interesting part is just jumping to the first error and finding where the Porcupine found something bad. And in our case, this is the simplest issue that you could reproduce. It's a case of etcd having a guarantee or maintaining a revision which is guaranteed to always increase, and we should be able to trace the revision from beginning, from revision 2, that every time there is an operation, the revision increases, and we can trace, there is a line that goes through all the requests, and you should be able to, or Porcupine should guarantee you that this line only exists and it only goes through operations that increase in revision, and you should be able to trace it through, but jumping to that it always goes by it doesn't decrease. And it's easy to see that something breaks here, because there is a combination of simple operations of update that has a revision 178, then a put that should always increase a revision and it goes to 179, and then a revision going back again. And because this operation always happens because before all the later operations, there is no way to create a line that would go into revision that it's still to the old revision. So which means etcd is not linearizable based on definition. You can that's a short version of what it means linearization, is to finding a line or for all operations that points to one, like even very small period, like one block, even very small block like this, like very, it can go very convoluted ways, but there should be always a way to cover some pick at some small time from the operation to and pass the line through all of them. So here it's a clear case. So if we go to the description of the issue, it's documented. I don't know where is there. I assume there should be one nice comment that describes it, but I don't think we had it here. But high level, this is durability API. Durability meaning you can do a write and then not get it back. And this is the exact case of, we did a write, the key 4 was set to this value, and we and this write got a revision 179, and then we lost the write, we reverted. And this is directly like so-called in databases durability property. Are there any questions for this? If not, I will go into the second issue. Second issue, 14685. This one, maybe before I describe it, for every time there is a failure in linearizability testing, we will, or the test will create a directory. By default, it will be in TMP. You can override it. It's described in README, but it will save all the interesting part. It will save the operation history for every client. It will save also watch history for every client, and it will save, also will copy the etcd data directory, so you can look at the wall, look at the DB file contents to get you a full reproduction. And this is also common when you try to look at the robustness test dashboard, which runs in CI. It will give you the same data from the it should include all the same data, and you can copy it locally and then analyze it and use it for reproduction. I mentioned the second issue. I don't know. I think that would be the only. I will skip the third one. Only do this one because it's unique. So again, we are compiling different etcd version 355, and configuring fail points, and then running it. And we already got a result. Here, the visualization is not as interest. Or okay, it also failed visualization. Okay, maybe it's interesting. I thought that was the watch issue.
I think it's the QPS one. The QPS is clicking.
Is there a watch? Oh, watch traveling. Okay, so I picked the wrong. I wanted to just show the second an example of watch going back in time. Let me pick the correct one. Again, nothing changes. It's just an automation for convenience, and I know nice demos. And it and I configured it wrongly. So the problem with the scripts, they sometimes can fail. I don't know if I have enough time, but it didn't find the test, which means, oh, this is the not nice. I disable it by default because it's file likey. But test. I don't know if it will. What did I do? Golang, I hate you with your commas. Yeah, hopefully it will reproduce. Yeah. Again, Golang is great. The issue described here is depends or needs etcd to send snapshot between members. Oh yeah. Yeah, not. Which means it. And sending snapshot between members was not configurable before 3.6, or how much it was not easy to, or it happened, but it required many more revisions, like 10,000 revisions between them. And this is long enough that it's too long to run in CI. It's just the test takes too long, so I disabled it. But yeah, we managed to reproduce by disabling all the safeguards, and you can see that linearization succeeded, but watch rule was broken, and it broke ordered. What does it mean? We found some revisions that were not ordered, and here is the log line that says guarantee watch was broken, and on client 4 and on revision 158. So how to test it? You need to look at the client 4 file, which is this one, the watch for it. And find 158. And because it's JSON, you need to know that this, okay. And okay, so this should find me all the events with revision 138, 58. So it happens a couple of times in file. So first time it happens is there is a growing revisions, and it reaches one like from, it seems, beginning, and it reaches 158. Then we jump down and we find it again. And where this time we find it after revision 1140. Something doesn't make sense. Yeah. So yeah, revision went from 1,133 or 40 to 158. That's bad. That's the correctness issue. That's or what it shouldn't happen. So this way we can, like, unfortunately there is no easy tool maybe yet for visualizing watch events. Maybe we could create one, but that's how I currently find it, because usually the log will say which revision happened, so I just look it up and try to make sense of JSON files. Yeah, that's high level how to reproduce the old historical issues. Any questions to that? Okay, I don't think we'll have time to go through the normally plan or the things that I planned, so I can move it. But quickly, I would want to touch on how to triage robustness tests failures. So my high-level approach is I try to go like first thing is to think about both, is this issue really issue, and what is the impact of the issue. So I usually start from checking if issue is test on test or on etcd site. How to do that? Every time, check if issue. It's pretty simple. We already did this. We had a scenario like with 1370, durability issue, and we looked. We had a failure in the test robustness test reported failure. We took the file and we read it and we checked. And by technically eyeballing the porcupine visualization, we could read that something is wrong. It's wrong because, in principle, how etcd behave, it should never behave like this. So the goal or the idea is, if porcupine would show a visualization bug and you could still try to, by human means, check if the operations make sense. If they make sense, it usually means that the issue is in robustness test model. But if we have clear cases like this revision going down, there is no reason to doubt robustness test, because the logic for dumping for collecting the client operations is very naive, very simple. It's more, or I lie. It's complicated, but it's really complicated. But it still should be clear enough that it shouldn't happen like in this example. So we should be able to see easily that this is a revision going down. So you need to know in principles how etcd works. Another approach, I think I once implemented it, but I haven't contributed it back because it's a little bit tricky, is if there is an issue, if the operations that are going through etcd there are so many concurrent operations that you cannot understand it. Try to maybe simplify the test, or better try to, I once implemented that, take the wall from the etcd, from the report, a wall file from data directory of etcd, and try to replay it by just start etcd on it, or you can configure robustness test to run on it. And if it reaches different results, and it means, depending on that, you means the same history applied by two different instances of etcd would lead to different end result, which is also a case of correctness issue. Second thing is maybe correctness versus inconsistency. Difference is, a correctness issue means could be any type of issue that etcd didn't behave as we expect. It could be lost watch event. It could be, I don't know, temporary lost write or anything. So if the issue was only temporal, it means that system should recover after some time or after the request happens. Sometimes it's not so, because, for example, for watch, if you have watch cache on Kubernetes side and etcd misses an event, the issue was temporal on etcd side, but it will not be temporal on Kubernetes side because it will be cached. So sometimes it's not always easy to recognize them, but overall, like, correctness issues should be temporal. When it goes into inconsistency is when the issue happens. If the issue, when it happens in 3-member cluster, it only affect one member. So depending on which member you ask, you will get different results, and the issue is persistent. Then we go into inconsistency, and this is much more scary, because then you have a cluster that was not broken for a second or like millisecond when the requests were run. It is persistently broken, and in a way that each member will return you different results. And this is scary because Kubernetes goes whack, and every application will go whack if depending on which member you ask, which is random in most cases, will give you different results. Like Kubernetes optimistic concurrency just breaks. You cannot, it's horrible. Third thing is if it affect all their releases. So the question is, is the issue only on main branch, or which versions we can reproduce it on, so that we know if there is customers or users affected by it. So this is easy to track. You just reconfigure robustness test to run on older branches or older releases, as in the makefile example. Last thing is, does it affect Kubernetes? This is sometimes a very hard thing to answer, but should be considered. And for example, latest revision decreasing after compaction, the issue here that Huawei found doesn't affect Kubernetes at all, because it requires someone to compact the latest revision in etcd, and Kubernetes will never do that. But it's not really clear if someone without Kubernetes knowledge. So here, usually you need to have knowledge about API machinery. Yeah. So the worst. So all those issues below would be estimate impact. An estimation of impact would be based on if it's temporal or getting into full. If it's just a correctness issue that will go through and disappear and no one will care, or is it a persistent and inconsistency causing inconsistency? Does it affect any existing release, and does it affect Kubernetes? So worst case are issues that we cause inconsistency, affects existing releases, and affect Kubernetes. I had one more thought, but I think I will leave it for later. So that's all. We are 5 minutes past. Sorry for that, but I think we can stop here. Are there any questions for now, or can we leave it to the next meeting? Let me know if the meeting was useful too. Hopefully.
This was really helpful. Thank you for organizing it.
Yeah, man, this was really helpful.
Okay. Glad to hear that. So the next meeting should be on May 8th. Correct me, and we will start when we stopped. So we will look at the recent issues, check out the robustness test framework. Fortunately, we had one failure, but I already tried it and it's nothing interesting. And we will talk about improvements. If you are interested, we already have a couple We have two recent correctness issue that are not yet covered by robustness tests. They're not easy to cover robustness tests, so you can look into them and think how to cover it, but I would not recommend to try to implement it because it's I've been working on them for a long time to get them. It's very hard. Unfortunately, it's pretty complicated, but I encourage you to try to think about them and why. You can look at my PR history and see. I have a draft for one of them. I have a draft ready and it reproduces, but merging it is very painful because a lot of changes needs to be made. So that's all for today. Thank you, everyone, and hope to see you in 2 weeks.
Thank you, Marek.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye bye.